Okay, gang, this is section 6.4. I'm going to get started on this today. And this is going to be on conditional probability, which in itself can be rather hard to understand. And I think the way the book puts it together, not real good, but whatever. I've created a couple what I call easier examples, and then we'll get to the book stuff. And this section will be broken up into a couple different parts. Okay, so what I have here, these are students at University Heights High School, if there was one. And we have all this data. So we got grades 9, 10, 11, 12, and then the total. And then of all the students, how many have their license? How many have a license with no recs? How many have a license with at least one rec? So that should take care of everybody. And then you got totals over here. Okay, so let's go down the chart. I want to find the probability first of a student as a sophomore. So out of all these students, and there's 741 altogether, 749 altogether, what's the probability of getting a sophomore? So sophomores, there are 197 sophomores out of 749 total. So the answer here is going to be 197 over 749. Okay, move that one over here. It's going to be hard to fit in. Okay, so now what's the probability a student had at least one rec? Well, at least one rec, that's these people. So there's 340 had one rec out of 749. Now, I haven't got the conditional probability yet. I will, though. The student has no license given the student is a sophomore. This word right here, given, that's a key word. That tells you have conditional probability. So we are given the student as a sophomore. So at this point, we use my ruler as a prop here. The only people we're looking at is sophomores. It's given at sophomore, so we're only looking at these people here. None of the other people matter anymore. So what's the probability they have no license? No license given they're a sophomore. Well, there's 65 people that are sophomores that don't have their license. That's 65 out of how many sophomores altogether? 197. So when we're given it's a sophomore, that tells us the bottom number. How many sophomores are there? 197. The first part says out of the 197, how many have no license? 65. Okay, let's go to number 4. The student is a junior given that he is licensed and has had no recs. So that means we're talking about this column, license with no recs. We're given this one. So that means the bottom number is going to be 160. Then the top number, we got to be a junior. So out of the 160, how many of them are juniors? 55. Now, I'm not really worried about taking that fraction, put it in lowest terms. I'm just trying to give you the effect, how you get the numbers. Number 5 says the student is a senior and has no license. Well, what's and mean? Is this given probability or conditional probability? No. This is the same thing we've been doing. It says and. So students that are seniors, here's the seniors, and no license, that number is going to be 30. There's 30 people that are seniors and have no license. That's your top number. So 30 people satisfy that result. What's the bottom number? Well, since it's not conditional probability, then the number is going to be 749. So unless you see the word given, the number on the bottom is going to be 749. Okay, here's my last one on this page. What's the probability that the student is a freshman or has a license with no rec? Well, when you see the word or, we have a formula for that. The probability, I'm going to put 9 for freshman, or means union. License with no recs. I don't know how am I going to put that. I'm just going to put no recs. The formula says to do this, you're going to take the probability it's a freshman plus the probability of no recs minus the probability, I'm going to just put both. This is similar to the formula. Last chapter we had this. We had the number in A union B. We said that was the number in A plus the number in B minus the number in A and B. That was the formula. And then we expanded that the probability. They use PR. I don't. I just use P. The probability of A or B or union is the probability of A plus the probability of B minus the probability of A and B. And that's what I used up here. So what's the probability that's a freshman? Well, freshman-wise, when you look here, there's 145 freshmen. That's 145 out of 749. Plus, what's the probability a student chosen at random has no recs? That's this number here, 160. So that's going to be 160 out of 749 minus, okay, now we want both. So that means they got to be a freshman. So that puts us in this line. And no recs, that would be this one here. That's 27 out of 749. So if we did that, we'll cheat and look up the answer here. Looks like it's 182 over 749. All I did was take 145 plus 160 and subtract 27 to get that answer. Okay, so this is a good practice on doing probability, and it also gave us 2 of these that were conditional probability. 3 and 4 were conditional probability. Okay, let's move on. And I don't think these are in the same order as what your outline is. I'm jumping to this first because I think it might be better for you. Okay, so let's say we're tossing a pair of dice, and then what we do, we add the dice scatter. So let's say we had a red die, that's why these are red, and a green die. So if I got a 1 on the green and a 1 on the red, those add up to 2. Or if I went down here, let's say I had a 3 on the green and a 4 on the red. 3 on the green, 4 on the red, that'd be a total of 7. So that's how that works. Okay, so let's say we're just tossing one time. What's the probability of getting a 6? That means a sum of 6. So if you look at the 6s, just the ones in the black, I got 1. Let's do this. Use my ruler again. Got 1, 2, 3, 4. I got 5 of them. We did this previous lesson. It's 5 out of 36. Okay. What's the probability of getting where at least one is a 2? Ooh. That means we could have a 2 on the green or a 2 on the red. So let's do this. So the probability of at least 1, 2, that means that's the probability of a 2 on the red or 2 on the green one. Which we know, let's just call this, that's P of R, this is P of green. So using that formula, that would be the probability of getting a 2 on the red one plus the probability of getting a 2 on the green one minus the probability of a red and a green. That's utilizing the formula. I just went through it on the other page. Okay, so what's the probability of getting a 2 on the red one? Well, that's 6 out of the 36, or 1/6. Let's leave it 6 over 36. Plus, now just before I go on, okay, so any of these guys right here, that 3, 4, 5, 6, 7, or 8, those guys work because they got a 2 on the red. So that's 6 of them. That's where the 6 comes from. The 36 is how many there are altogether. Now, what's the probability of getting a 2 on the green one? Well, that's all these guys. 3, 4, 5, 6, 7, 8 on that line. So there's another 6. So I had 6 this way and 6 that way. So that's total 12. But the problem is I've counted this 4 twice. So that's why you have to subtract 1 out of 36, because this one right here, that's 1 out of all of them together. So when we do that, that's going to be 6 plus 6 is 12 minus 1 is 11 over 36. Okay, so I'm going to transpose it. That's 6 over 36 plus 6 over 36 minus 1 over 36. Oh, I did that wrong. 1 over, what was it? Yeah, 1 over 36. So that's going to be 11 over 36. Okay. What's the probability of getting a sum of 6 and at least 1 6? And at least 1 is a 2. I really could think of this logically. So if I said, what's the probability of getting a sum of 6? So if you look here, how many 6s are sums? Those are the black ones. So I'm looking here, I got 1, 2, 3, 4, I got 5 of them. But it says one of them is a 2. So if I'm looking at these 6s, put on the other side, out of those 6s right there, how many of these 6s used a 2 to get it? This one used a 5 and a 1, so no. This one used a 4 and a 2, so that one counts. So I had 4 plus 2 gave me 6. This is 3 plus 3, no. This is 2 plus 4. 2 plus 4 gives you 6. And the last one's 1.5. So how many do I have there? 2. 2 out of what? 36. It's not conditional probability. And I know I could write that as 1 over 18. I'm just going to leave it as 2 over 36 for right now. Okay. Notice the difference in C and D. The only difference in the questions, I've got an and here and an or there. So you could get a sum of 6. Let me see something here. I'm probably going to regret this, but let's just say I'm going to use a highlighter. So if I was talking about getting a sum of 6, and I think it's better for you to think logically on this, a sum of 6 would be these guys right here. There's 5 of them. And then it says, or at least one is a 2. Well, it doesn't have to be a sum of 6. It just has to have a 2 involved. So that works, that works, that works, that works, that works. Or going down here, 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 and here. All these have a 2 involved. So I could have a 2 on the green one. I could have a 2 on the red one. Or I could get a sum of 6. So when you count all those up, just count the yellows. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 14 out of 36. Now, I could also do this. Here's mathematically how you're supposed to do it. So it says the probability of getting a sum of 6 or a 2. Doesn't matter where the 2's at. So we got to find the probability of a sum of 6. We're going to find the probability of getting a 2, not a sum of 2, but just a 2. And we're going to subtract the probability of both. So the probability of getting a sum of 6, that was 1, 2, 3, 4, there's 5 of those out of 36. Plus the probability of getting a 2. I just did that one up here, where at least one is a 2. That was 2 over 36. Minus both. So where did you have a sum of 6 and having at least a 2? Well, I had one right here. Is that right? Yeah. Yeah, right. Yeah, right there and right there. There's 2 of them. Wait a second. I got something out of line here. I'm sorry. This is the 2 out of 36. This number was 11. A sum of 2. You had 6 there, and 6 there minus 1 gave you 11. That was this number I found up here. I miscopied. I copied that number instead of this one. So basically, I laid the groundwork. It was this one plus this one minus that one. So 5 plus 11 is 16 minus 2 is 14 out of 36. And you get the same answer. So when I highlighted, I was kind of showing you a logical way of doing it. And then down here, I showed you the mathematical way of doing it. So 14 over 36. Okay. Now, C. I see this word right here. And you start looking for those special words. And is special, or is special, and now you got given. This says, what's the probability of getting a sum of 6, given you got a 2 on the first roll? Okay, so let's assume this is the first roll, and that's the second roll. I was using red and green, but just say first roll, second roll. So if I got a 2 on the first roll, I'm given that it's on that line right there, all those in yellow. So the bottom number will be 6 because there's 6 of them. 1, 2, 3, 4, 5, 6. Out of those 6, how many of them gave you a sum of 6? 1. That's this one right here, 2 plus 4. So that was 1 out of 6. The second part, whatever you're given, gives you the bottom number. And then out of that bottom number, that becomes like a new sample space. Once it tells you this, we're not talking about any other numbers. So out of those 6 numbers, how many of them gave you a sum of 6? 1. Okay, and let's look at the last one. This is a given. This one reverses it. What is the probability of having at least one die showing a 2 given a sum of 6? So now, this is the last one, yeah. So let's just do this. A sum of 6 would be those guys there. So my bottom number is going to be what? How many are in there? There's 5. 1, 2, 3, 4, 5. Okay. Now we're given it's a sum of 6. Now, out of those 6, how many of them used a 2? This one did, because I took 4 plus 2. And this one did, because I used 2 plus 4. So out of the 5, 2 of them used a 2 to get that answer. Okay. So I'm trying to show you probability, kind of a review on basic probability, but I'm also mixing in some ands and ors, and you're starting to get an idea of conditional. Okay, I think I'm going to do this one, and then that'll be the end of part 1. I'm going to break it into parts because I think the other parts get a little more technical, and I could lose you real quick, so I'm going to give this to you first and let you look at it. Okay, so conditional probability is probability that depends on a previous event happening first. Okay, so here's my example, college students. It says, suppose a certain mathematics class contains 26 students. Of these, 14 are economics majors, 15 are first-year students, and 7 are neither. Usually you have both, but this is neither. Suppose that a person is selected at random from the class. And I got 2 probabilities here. Okay, now what they don't give you is what I just put my hand over. When it's like this, it's very hard to understand what the problem is unless you draw a picture, and that's the Venn diagram. And I've already got the numbers in there. But let's see if we can figure out what they are. First of all, 7 are neither. That means the 7 goes out here. Those represents the ones that are in neither circle. So we started with 26 students total, and we're going to subtract 7, and that leaves 19. That means there's 19 students inside here. What we don't know is we don't really know the breakdown. We have to figure out what those numbers are. I know I've got them written in there, but we've got to figure it out. What I do know at this point is whatever numbers are inside the circles, they have to add up to 19. Okay? Now, what I do know is the number of econ people is going to be equal to, what was it up here? 14. And the number of first year is equal to 15. So now I've taken those numbers and I've written them down here. That's all I've done. So now we remember that formula. The number, and I'm going to E or first. E for econ, first means first year student. That's equal to the number of E plus the number first-year students minus the number in, and again, I'm just going to say both, so this number here is this. That's the 19. That's everything inside the circles. The number in E was 14. And the number of first-year students was 15. Minus, I'm just going to put a question mark. So these two add up to 29. So what you're saying is 19 is equal to 29 minus what number? So that number is equal to 10. And that number, if you'll remember, is the number that's in econ and first-year students. That's where that number came from right there. Then once you have that number, you remember econ has 14 altogether. So if you take 14 minus 10 gives you 4. That's where that number comes from. And on the other side, if you take 15, there's 15 inside this circle. So 15 minus the 10 I found, that's where that 5 comes from. And the 10 came from here. Now, let's go to the question. It says, what is the probability that a person selected was both an economics major and a first-year student? Keyword is and. If it's and, that means it's on the inside. That's the 10 out of how many? 26. And yeah, I could write that as 5 over 13. B says, suppose we are given the additional information that the person selected is a first-year student. Given. We're given this. So we're given it's a first-year student. That means that's the top or the bottom number. So a first-year student, there are 15 of them. So that 15 goes on the bottom. Okay, now, out of those 15, what's the probability that it's an econ major? I didn't write that correctly, but what's the probability it's an econ major? So at this point, we're only looking at that circle, those 15. Out of those 15, how many of them are econ majors? 10. And yeah, you could write that as 2/3. Probably should. I'm just trying to make it simple. So once you're given something, that's going to reduce the number that you're actually looking at. So once we were given a first-year student, that cancels out all the other numbers. We're not looking at anything else. This becomes our new sample space, if you want to think it that way. And then out of those 15, how many of them are econ students? The 10. That's the circle overlap. Okay, so now you're getting a better idea of everyday problems with conditional probability. Okay, I think I'm going to stop there. I think it's a good place to stop. As we go on, they'll get a little bit tougher. Okay, thank you.